Hi, class. Welcome. Today we are going to continue talking about chapter 2, which is called ultrasound, sound we don't hear. We're going to start on page 23 under the topic of attenuation. So, attenuation means the weakening of the sound wave. As the sound wave travels through an individual's body, it will always weaken. This is true for whatever it is going through, regardless of that tissue or of the medium, the sound wave will always weaken. And we're going to talk about why does the sound wave weaken, in what ways, like what causes it to get weaker instead of get stronger or maybe just like stay the same in strength. So we're going to pick up on the under attenuation, and attenuation means weakening of the sound wave. It's also described as a reduction in amplitude, power, and intensity. And I will start reading and I'll tell you what to highlight, what the most important ideas are. Okay. So it says we now consider the magnitude. Magnitude is also called strength, and you should know those words interchangeably. So it says we now consider the strength or the magnitude of a cyclic variation in a continuous or a pulsed wave, ultrasound wave. Highlight, amplitude, and intensity are indicators of strength, of the strength, or again, the magnitude of the sound. He forgot one, so it's amplitude, power, and intensity. It's not just amplitude and intensity. So go ahead and write that third word in, power. And then these are indicators of how strong or how intense the ultrasound is. So if you say something has a high amplitude, most of us would definitely know that it's like something, if you describe something as being high amplitude, it's like very powerful, right? Um, so high amplitude, high power, or even high intensity, it's just like something that's powerful, right? Like you think of something that's strong versus something like low amplitude, low power, and low intensity. So amplitude, power, and intensity, these are three words that describe the strength or the magnitude of the sound wave. They're together as a group, they're called the three bigness parameters. Um, so we're going to learn each one individually. What is amplitude, what is power, and what is intensity? But together, they're part of a group. They're called the three bigness parameters, and they are directly related to each other. So if you say something that has high power, it also means it has high intensity and it also has high amplitude. If I say something has low amplitude, it also means it has low power and low intensity. So they're always going to be the same thing at the same time. So if I say intensity increases, then you just know like, oh, so does amplitude and so does power, right? If I can use any of those, right? If I say like power decreases, then you know so does amplitude and so does intensity. I call them API for short, which I know are the three biggest parameters that are amplitude, power, and intensity. Our first word that we're going to learn, our first term is amplitude. And what you need to understand first before you get busy writing everything down is if you look at this image here. So this red line that's stable or stationary, right? It's just like one straight line. There's like no curvature to it. This represents your pressure and density in your body when you are not getting an ultrasound. So right now, because you're not getting an ultrasound at this very moment, and you're probably just sitting in front of a computer or something, um, if we measured the pressure and the density and the particle motion in your body, there would be like they would all be stable, like not changing, right? Like I'm sorry, pressure isn't increasing in your body, it's not decreasing, it's just like at one normal, average, undisturbed value, okay? So these red lines signify or represent pressure and density and particle motion, because those are the three acoustic variables that are directly related to each other. This represents normal pressure, density, and particle motion, average pressure, density, and particle motion, undisturbed value of pressure, density, and particle motion. This sinusoidal wave, right? You guys all know what sinusoidal now means. That means a smooth curved shape is described as sinusoidal. So this represents, here it is, pressure and density and particle motion increasing to a maximum value and then decreasing to a maximum value. I know that sometimes people are like, well, why do you say decreasing to a maximum? Shouldn't you have said decreasing to a minimum? Yeah, it is like the minimum value, the lowest value of pressure and density. So that means like the lowest that the pressure and density will ever be in your body is right here. But like whatever that means, like pretend there's a number or something associated with this part. But anyway, what I'm trying to say is that if you look at the definition for amplitude, it says the maximum variation of acoustic variable. So they're saying the max variation, like how much, in other words, you can translate these two words, maximum variation. You can just switch these words out for like how much does an acoustic variable change in the body? That's it. They're not saying how much does an acoustic variable increase in the body. They're not saying how much does an acoustic variable decrease in the body. They're just saying how much variation, like how much does it change from the normal undisturbed value. Okay. And we know when pressure and density changes in the body, it will increase and it will decrease, right? Amplitude, though, this word amplitude doesn't really care if the pressure and density increases or if the pressure and density decreases. It doesn't care like which way the pressure and density are going. Amplitude doesn't care if like there's high pressure and density or low pressure and density. All it cares is about is knowing like how much did pressure and density change? Like whether it increased or decreased, amplitude doesn't care about the direction. It's just like how much did it change? And so like you can see like on this wave here, just the fact that it goes like much higher away from the baseline. And the baseline, remember, is normal pressure, undisturbed density, average, right? So like you could like even just from this picture, you'd be like, oh wow, yeah, pressure and density and particle motion really, really increased to a maximum value. But then pressure density and particle motion also decreased to another maximum value. This is the max negative, but it's still a maximum, right? This is max positive pressure and density. This is max negative pressure and density, but like nonetheless, it's still max, right? And so it's like, why do I keep saying this to you guys? What I'm trying to get across to you is these are the three definitions for amplitude. However, we typically will not see this one. So I do put a line through it just because of the word minimum. You probably will not randomly, you probably will not see the word minimum. So the definition of acoustic variable that you should probably study so that you see it on the test and know what it is, it's the maximum variation of an acoustic variable. And so like basically in other words, again, switch the words out. How much will an acoustic variable show variation? How much variation will it show? How high will pressure and density get? How low will it get? It's also described as the difference between the max and the average. Okay, pay attention here. It's called max and average because, uh, nope, that is not great. That is not what we wanted. Okay, I gotta get this somewhere here. Okay. So what I'm saying is it's a difference between the maximum value to the baseline, which is the normal undisturbed value, right? It's a measurement from the maximum value to the average, which is, the baseline. It's always a measurement from either the peak or the trough to the baseline. Okay, so this would represent, because it has like an arrow here, or even if it just had one arrow here, this would represent amplitude. Okay, if you're ever shown a picture where the arrow is actually going like from a peak and like to all the way down to a trough, okay, so like to the bottom like that, not stopping at the baseline, but going right through it. So this is also called amplitude. This picture represents amplitude, but it's called peak to peak amplitude. So like they're basically saying like this is a peak and this is the peak down here, right? So like sometimes they draw the arrow like this, like straight up and down, or sometimes they will put it like this, right? But if it's going from like one peak to another peak, or like from one peak all the way down to like where the other peak would be if it was on the other side, that's peak to peak amplitude. If it stops at the normal undisturbed average baseline, and then it goes either to here, or it can, remember, go this way too. This picture represents amplitude. Okay. So, because again, it's maximum. So think of this would be one of the peaks and the average, and this would be the baseline. Okay. Um, it is the units for amplitude are megapascals. It is determined by the sound source. It is sonographer adjustable. A lot of times they ask us on the test if amplitude is sonographer adjustable, and yes, it is. So is power, and so is intensity, right? The three bigness parameters, API. And I'm going to explain to you how we adjust amplitude, power, and intensity. And the typical values for amplitude are 1 to 3 million megapascals. So the way we can change all three of these, remember, you already should know two things about them. They are directly related. That's number one. So I'm going to put DR for directly related. And number two, they are sonographer adjustable. And so let me explain to you how they are sonographer adjustable. So they're sonographer adjustable when you go into the lab and you are scanning an abdomen and you put the preset on the machine abdomen, right? You put it in the abdomen package. And so that means that somewhere on your screen, it will say abdomen, like somewhere at the top. And so then you start scanning, right? So basically what you did at that point is like you told the machine, like, hey, machine, I'm going to scan an abdomen. So use whatever settings are programmed for abdomen. Like maybe it's like this level of, you guys don't know yet in chapter 4, we talk about the different parts of the machine. So we talk about like what part of, and also the transducer, we're going to learn like what, oh, there's just so much, how the beams are made, how they're transmitted into the body, how echoes are received. Anyway, but what you're doing when you pick a package is you are basically just telling the machine, like, hey, machine, I'm going to scan an abdomen. So, like, put those settings, like, you know how on your phone, when you use different filters, like, some filters will give you like brighter images or darker images or smoother images or like more gritty images, right? Like, so all those different filters on your phone, you can make your appearance look different, right? So like think about a package almost as a filter. Like you're going to make your pictures look a little bit different. Like, but a really big important part of setting the right package is like not only are your pictures going to look a little bit differently, but it's um what intensity is being used in that sound wave. So like our sound waves are all FDA approved. So like every sound wave that comes out of those transducers in the lab that you're using, they're all FDA approved. And so there's like a specific intensity of the sound wave. Imagine like this is a good thing because what it does is it limits how intense our sound waves can be when they come out of our transducer. Because what you're thinking about is like that sound wave is coming out of your transducer, but it's going into a human body, right? It's going into your patient. If that sound wave was really, really high, like if that sound wave had a really high amplitude, power, and intensity, it could potentially harm the patient in different ways, which we're going to talk about at the end of physics. But one thing that you guys already know, like what happens to the particles in your body when the sound travels through them? It oscillates the particles in your body and it also heats, right? Tissue temperature elevation. So what if there was no FDA standards and like the FDA was like, we don't care. You can shove as many ultrasound machines into hospitals as you want, and you can use whatever machine you want, and the sound wave, the beams intensity can be as high as you want. And we're over there doing ultrasound on all these patients, like literally like damaging the inside of their bodies because we're like burning them. Like it's just such a weird thought that we like don't really think about, but it's because our sound waves cannot like there's like a limit. They can't go over like this much amplitude, power, and intensity. That means they can't be so strong that we're like causing bodily harm to our patients. However, you have to also consider when you're scanning a fetus, think about it. That baby is underdeveloped. That baby, the tissues are just starting to develop. So like just because transducer is sending sound waves that are safe for my body, like I'm a grown woman, you know what I mean? Versus a fetus that's barely just starting to develop like tissue layers and cells and things like that. Like just because it's safe for me, right, doesn't mean it's safe for the baby. So every time you go into the lab and you set a preset, you are basically telling the machine what you are going to be scanning. And so then like at that point, the machine is going to know like, okay, if this ultrasound tech clicks on abdomen package, then I can have this setting of amplitude, power, and intensity for my sound wave. And then like if you put it in the OB package, obstetrics, which means you're telling the machine that you're going to be scanning a baby, then the machine is going to automatically reduce the amplitude, power, and intensity of the beam because you just put it in the OB package, telling the machine like, hey, I'm scanning a baby. And so like we can adjust amplitude, power, and intensity by selecting the correct packages. Um, and so that is why we have to do that, right? Because you want to make sure that you are on an OB package if you are going to be scanning a baby so that you are going to be using the lowest amplitude, power, and intensity of the sound wave that's possible because you don't want to cause any harm to our patients, right? So you think about these three bigness parameters. I want you to remember that they are directly related. If one goes up, they all go up. If one goes down, they all go down. But number two is excuse me, number two is that they are all sonographer adjustable. Okay. Our next word is power. It is defined as rate of energy transfer or rate at which work is performed. The units are watts. It's determined by the sound source. It is sonographer adjustable. There are the typical values. Don't forget to always put any numbers that we see, any values on our numbers list, any equations that we come across, put it on your equations list. I try to remember and catch them every single time to remind you guys to do it, but like also, I can make mistakes. So just do it if you remember. We also want to know the definition of energy. So energy is the ability to accomplish work. I always remember that definition first because I always think about like what I would say if I had to say like I need to have the ability to accomplish work. Like what makes me able to accomplish work is having energy, right? Like if you're like, oh, I gotta clean my house, I gotta vacuum, I gotta sweep, I gotta this, that, and the other. And if you have no energy, you're probably not going to do those things. So you need energy to accomplish work. Okay. And then moving that work around from place to place. So transferring energy. And we're going to look at a slightly different definition in your book. That is called power. Okay. Um, and then I'll I'll do intensity too, and then we'll go and highlight from the book. So intensity is described as the concentration, right? How intense is something? How concentrated is it? So the concentration of energy. It is also defined as the rate at which energy passes through a unit area. The units are watts per centimeter squared. Determine cell source, sonographer adjustable, yes. Typical values 0.01 to 300 watts per centimeter squared. The intensity is defined as power divided by area. This right here, okay, so numbers lists right here, right? And then here is the equation. Intensity is power divided by area. Average intensity, which is different than intensity. So intensity and average intensity are different, is total power divided by cross-sectional area. And we're going to talk about why do we need to have one equation for intensity and one for average intensity? What is the difference? Why do we need that? And then important in bioeffects and for safety discussion. So, okay, listen to this because this is important. Amplitude, power, and intensity, they're all bigness parameters. They're all determined by the sound source. They're all sonographer adjustable. They are all words that describe the strength and the magnitude of the sound wave, right? They're directly related. And I'm going to go back to that as well, too. So we know all these things, but intensity is like the Beyonce of the group. Intensity is the one that the test mostly talks about. So you might have a couple questions on power, you might have a couple questions on amplitude, but questions on intensity are going to be a lot more because it is more specific to how our ultrasound beam works. And so all of the information for intensity you have to know. The reason that amplitude, power, and intensity, and especially intensity, is important is because of bioeffects, right? When the sound wave is traveling through our body, we need to know how the sound wave is affecting our biological tissue. What are the effects on our biological tissue? How does the sound wave affect our body, right? So we know the sound wave is going to affect our body by elevating temperature and by causing oscillation, pressure differences and density differences, right? Particle motion. And so that's what we know so far. But remember, ultrasound has to be safe for it to be able to be used, right? So that's why bioeffects is so important. We need to know how the sound wave is affecting our body. So before we move on, I want to just kind of follow up with the book. So you should have the information in your notes on the three bigness parameters, and then we're going to add a little bit more to it, but we're going to just jump to the book for a few minutes so we can kind of catch up. So, um, the title of this section is attenuation, which we know is a reduction in amplitude, power, and intensity. We know it's a decrease in beam strength or magnitude, right? We know it's the weakening of the sound wave. However, we do need to know like strength words before we can even talk about strength being taken away from the sound wave. So our first one is amplitude. You're going to highlight the definitions. So if you have a definitions highlighter, amplitude is the maximum variation that occurs in an acoustic variable. Amplitude is a measure of how far a variable gets away from its normal undisturbed value, and this would be its value if there was no sound present, no ultrasound present. Amplitude is the maximum value minus the normal undisturbed or no sound value. And then for the definitions, and you want to highlight the units, which are megapascals. And this would be a good place in your book, just kind of squeeze it in there. I always draw this picture. So I draw this, and then I draw this, I put my baseline, and then I draw a picture where I'm doing an arrow from the max to the average, and then from this max to the average, right? And sometimes you even want to remind that he's going to call both of those maximum, right? And this is my normal, undisturbed, what did he call it? Average, right? You can write the whole thing. Normal, he calls it undisturbed, he calls it average. So this picture here represents amplitude. Okay, and then I draw another picture. So I usually draw it like that, to be honest, right? And then I put if they're talking about maximum to minimum, right? Or like maximum to maximum, and they're not talking about that baseline at all. They're not mentioning that at all. That is peak to peak amplitude, right? So I just want to make sure that there is a difference between that. So I put that in my book there. Okay. Go ahead and skip down to intensity in your book, and we're gonna highlight this definition for energy, the ability to accomplish work, and then it says sound can do work. And if you flip to the other page, it can vibrate objects in its path or raise the temperature of the medium through which it is traveling. Then definition now, power is the rate at which energy is transferred from one part of the system to another or from one location to another. So the main idea for power is like transferred energy. When I try to memorize definitions. I definitely cannot remember them word per word. I just remember like two or three of like the main words and like the main ideas of the definition. And then I kind of go with that. So remember that energy, ability to accomplish work, right? I need the energy to be able to accomplish work. Power is spreading that energy around from, look what he says it very vaguely. He says one system to another. So basically, he's just saying like from one location to another, not being very specific of a location, just like moving that energy around, transferring the energy. And then highlight power is energy divided by time, and that should go on your equations list, and you should definitely remember that. And then you guys also want to highlight that the units are watts. And then we're going to skip down to the next paragraph, and this is a definition. Intensity is the rate at which energy, so still transferring energy, passes through a unit area. So there's three definitions, guys, right? Energy, power, intensity. Okay. And amplitude, but like amplitude is kind of like just like you just remember those definitions. So, right, ability to accomplish work, okay, transferring energy. So I'm now taking the energy, I'm putting it down here, transferring energy, okay. And now it's like transferring energy per unit area. So now I'm taking this, and I'm bringing it down here. See how like you know energy, it can help you with power, and then if you know the definition of power, it will help you with intensity. And but this is specific, it's like area, per unit area. And then just like the definitions for amplitude, which we started off with. Okay. Um, and then you're gonna, so you highlighted intensity is the rate at which energy passes through a unit area. It is equal to power divided by area, power divided by area. And then in the next column over at the bottom of that paragraph, highlight the average intensity of the sound beam is the total power in the beam divided by the cross-sectional area of the beam. So going back to this, why do we need, here we go. Why do I need a definition for intensity and for average intensity? So the definition for intensity is power divided by area, right? Just like straightforward power divided by area. But if we're talking about ultrasound, and be careful how the test is going to word it, are they going to ask you to define intensity or average intensity? If they're talking specifically about ultrasound, right, the better one would be average intensity. Okay, so intensity is power divided by area, but for ultrasound, it's better for us to use the equation for average intensity instead of just intensity. And the reason is our sound wave is not uniformly intense. So without going too far into it, because we haven't really gotten there just quite yet, I just want you guys to know that here's our transducer, right? And then the sound wave is coming out of the transducer in its, trumpet shape, which, we remember we had to learn it. Look, we had to learn about those sinusoidal sound waves, those squiggly lines, because we had to understand our acoustic parameters, right? We had to understand our continuous wave acoustic parameters. What are continuous wave acoustic parameters? There's three. So this would be acoustic parameters that describe continuous wave, right? And continuous wave is cycle after cycle after cycle, forever. So me saying what are acoustic parameters that describe continuous wave is the same as me saying what are acoustic parameters that describe cycles. So your cycle words, frequency, period, wavelength, okay? So what are your acoustic parameters that describe pulsed wave sound? Remember with pulsed wave, where there's a pulse and then an off time and a on time and an off time and a listening time and a talking time, a listening and a receiving, the pulse and the echo. That's what's used for imaging, right? So what are our acoustic parameters that describe pulse wave sound is PRF, PRP, PD, which is pulse duration, SPL, which is spatial pulse length. So the reason we used to know how to draw those squiggly lines is because we needed to know how to understand those acoustic parameters. But really, our sound waves look like this. They look like they have a trumpet shape to them. And there's parts of the sound wave that are more intense than others, okay? The most intense part of the sound wave is going to be this part right here. This is called your focus. So you see how the sound wave gets really, really nice and tight and kind of like pinches at one area. That pinched part of the sound wave is called the focus. This is where the sound wave is the strongest. It has the highest magnitude. So what does that mean? That means that at this area right here, which is the focus, the sound wave is the strongest, has the highest magnitude because it has the highest amplitude, power, and intensity, the highest API. Okay, the more the beam is spread out. So, for example, if you look right here, look at how spread out the beam is right there, right? It's not pinched, it's the opposite, right? So when a sound wave is more spread apart than tightened, then so like once again, from here to here, right, it's really tight. But like from here to here, it's not very tight. Right here, it's not very tight, right? So that's where there's actually in this widened part, that's where your amplitude, power, and intensity actually go down. So think about it like this. Think about it like this. If you have a sound wave and it's filled with amplitude, power, and intensity. But at the focus, all of the amplitude, power, and intensity is squeezed and pinched into this like little teeny tiny area. That little area is going to be really, really high amplitude, power, and intensity. So because our sound waves do not have they do not have uniform amplitude, power, and intensity, and because the amplitude, power, and intensity changes depending on the location within the sound wave, that is why average intensity is more beneficial for us to study as ultrasound techs versus just straightforward plain intensity, right? If I told you that our sound wave has the exact same amplitude, power, and intensity everywhere within the sound wave, then you could just study intensity, right? Because all of the intensity is exactly the same everywhere within the sound wave. So, and all areas have the same power. You see that? And that's when you would use intensity. But our sound wave does not. So different sections have different intensities, right? And that's how our sound wave is. Um, and so you do have to know both of those. It's kind of like shining a flashlight onto your wall. When you're sitting there and you shine a flashlight onto your wall, you know that like in the center of that circle of light on your wall, the center is like really, really, really high, intense light. And then as it starts like expanding and you're looking more towards like the sides of the circle, there it's getting dimmer and dimmer, like darker and darker until the light just like completely fades away, right? And so it's kind of like that. The intensity in our sound wave is highest in the center as well. Okay. Um, so other things that you need to know about intensity is that when intensities are studied, so they in the book it says when they are reported, studied, or reported, they are studied in regards to time and space. So they look at the sound wave at different times and they look at different places or spaces of the sound wave. So just by like looking at this picture here, because this kind of has helped me like okay, so again, this is the area of the focus. That's why the intensity looks so hot. And there's even like red and yellow there, right? That has the highest API, amplitude, power, and intensity. And they're showing you that there's actually 2,000 watts per centimeter squared of intensity right there. And then here, where the sound wave is all big and spread apart and like wide diameter, here the intensity is only 10, right? So it went from 10 to 2,000. And so now you have to know that if the scientists study intensity here, or here, or here, or here, or here, wherever they study this intensity along the sound wave, it's going to vary. So they have to study it in regards to time, which means for us in physics, we don't say time, we say temporal, and space, which is spatial. So I want you to remember that intensities are important because they are important in the study of bioeffects. So we have to study intensity so that we can understand bioeffects, so that we're not causing tissue damage to our patients. There's a few, excuse me, there's a few intensities in your book. So if you go to page 25, this is a big advanced concept box. So look at number 1 in that box. It says, like a flashlight beam highlight, intensity is not constant or uniformed. You can add or uniformed in because it's not there. Intensity is not constant or uniformed across the sound beam, but is usually highest in the center. And then you can also write the note to yourself that this is exactly why, because it's not constant, because intensity is not constant along the sound beam, this is exactly why we study intensity in regards to space, spatial, or time, which is temporal. Okay. Also, in that same box, you have some letters numbered off from 1 through 6. So SATA, SPTA, SAPA, SPPA, SAT, SATP, SPTP. So those are intensities from lowest to highest. And so you do want to remember that list, okay? That list it seems a lot harder than it is. Anytime it says S, that means spatial. Anytime it says it's average, right? Anytime it says T, it's temporal. Anytime it says P, it's peak. Okay, so you have spatial and temporal, which we said already that we have to use those 2 letters all the time because we're talking about how the intensity is not uniform within the sound wave and how the intensity does vary within the sound wave spatially and temporally. And then attached to those S's and those T's, you're going to either have average, which is like a normal value for intensity, or peak, which is like the highest value for intensity. So like the more A's you see, the weaker the intensity is. The more P's you see, the stronger the intensity is, okay? And so you can see in that list, 1, 2, 3, 4, 5, 6, the number 1 is S average, P average. So spatial average, temporal average, right? And so anyway, you just want to remember the order. Typically the order, the ones that they ask the most about is number 1, number 2, and number 6. And everybody will get questions on number 2 because look what it says, that is the one that is, so for that one, write down, I think I have it here too. Yeah, I do. So you want to know that SATA has the most minimum value of intensity, SPTP, right? Because that's 2 peaks is the maximum, but 100% everybody will get this question. SPTA, spatial peak temporal average, is the most relevant intensity in regards to tissue heating. So they're saying that like, yeah, we can study spatial averages, spatial peaks, temporal peaks. We can study all that stuff, but the one that's the most important for ultrasound is SPTA. You just got to remember it. Even if you don't really understand it, it's just something that we have to memorize. So you also have to know how I mentioned earlier that these are directly related, right? The 3 bigness parameters, amplitude, power, where is it? Amplitude, power, and intensity. These 3 words are directly related. However, if on the test they say, is amplitude, power, and intensity directly related, you have to say false. The only time you can say true is if you see the word squared, or if you see like amplitude squared. Okay, this too is a really big deal. So if it says something like true or false, amplitude is directly proportional to power, is directly proportional to intensity, you would say no. That's a false statement. It has to say amplitude squared. This is just something you're going to have to remember. And so I typically write it like that. When I write it like this so that I don't forget my important squared. Okay. And the reason is because remember how amplitude be a measure from this maximum to average or this maximum to average. There's like two options, right? So that's the way I've always remembered it, that it's amplitude squared because there's two options. And so this is really, really important, okay? And there are going to be questions that are designed to kind of trick you a little bit and leave out the amplitude squared, okay? I also like to look at this box, this picture here. As you can see, this is a small area box and this is a large area box, right? In a small area, right? So what's a small area? Think about your sound wave. So here's my sound wave. What's my small area? Was this part right here, right? And what did I tell you guys? So that's a small area. What did I tell you guys happens to the API, the amplitude, power, and intensity in small areas? It goes up. You're taking all the amplitude, power, and intensity and squeezing it in this little teeny tiny area, which means it really is going to increase the amplitude, power, and intensity, right? If you think about your sound wave again, what happens when the area is wide, like this, like a big area, right? The amplitude, power, and intensity is going to be a little bit more spread out and not so concentrated, and that's why it's going to be diminished. So the idea here, guys, I don't care if you remember the sound wave. I don't care if you remember these big yellow boxes. I like to remember these big yellow boxes. I just remember small box, the arrow's going up, and I remember what the arrow represents, which is API. Big box, but the arrow's going down. And so this is for you to just understand the relationship between amplitude squared, power and intensity with area. So remember, these are directly related, but they are inversely related to area. So if area increases, API decreases. If area I forgot what I said, but the opposite of that, right? So if area increases, those decrease. If area decreases, those increase. So these are directly related. I'm going to put a D here, but they're inversely, I'm going to put an I. They're inversely related to area. Okay, and the last thing I want to tell you before I end this video is the bottom of page 24, that last paragraph, and what that means. So this is something that we've seen on the mock SPI, but not on the real SPI. So in that last paragraph, you're going to highlight intensity is an important quantity in discussing bioeffects. And then if you go to the very last three lines of it, that's the part that I'm referencing when I say that, like, I've seen it on the mock, but not on the real. And you guys are going to be taking both, right? At the end of physics 160, you take the mock, and then eventually you take the real one. It says intensity is proportional to amplitude squared. But we know that, remember? Because look right here, guys. We had already said power is proportional to amplitude squared. Intensity is proportional to amplitude squared. Power is proportional to intensity. So no matter how I mix and match these three words, I always have to say amplitude squared, right, to make it correct. So he says intensity is proportional to amplitude squared. Good. So far, so good. He says, thus, if amplitude is doubled, intensity is quadrupled. If amplitude is halved, intensity is quartered. So not super important, but he's just trying to get you to remember a little bit of math. And so sometimes at first we don't like it. Most people I notice, like, they kind of don't like math. They're not super stoked about it, but this is pretty easy and I can show you. So we know, you can write this down. We know that intensity is equal to amplitude squared, okay? So he says if amplitude is doubled, okay? I'm going to write that backwards. I'm going to say amplitude squared is equal to intensity. And the only reason I want to write it backwards is because it'll be easier to follow the math, okay? So in his first example, I'm going to put number one because this is his first example. He says amplitude is doubled. Okay, so if amplitude is doubled, it would be like this, a doubled 2, right? And so that's the same as saying 2 times 2, which 2 times 2 is 4. So then he says, okay, so if I take amplitude, right, and I double it, I'm going to get a 4. So that means my intensity, right, 4, instead of saying 4, though, he says quadrupled. Okay. His second example, I'm going to put it in orange. His second example, number 2, he says, what if amplitude is halved. So I'm going to take this, right? Because I'm still about amplitude and halve. So half is 0.5 to the second power. Because again, we always have to have that little second power because it's amplitude squared. 0.5 to the second power is the same as saying 0.5 by 0.5. And what you get there is a 25.25. So therefore, intensity is going to be what's 25? It's a quarter. Right? So like this is this, and 4 is quadrupled. So you don't have to remember the math because the math doesn't matter. Sometimes people just remember amplitude doubled, intensity quadrupled, right? So if numbers is not your thing, I hear you. Because it's not my thing either. So if you want, you can just remember it like this, right? You can remember amplitude, power, and intensity are all directly related. And remember your two examples. Number one, if they say amplitude is doubled, it means intensity is quadrupled, right? And number two, he says his amplitude is halved, then it means intensity is ordered, right? So leave the math out. If you don't like the math, then don't remember it regards to math. So the title of this section was attenuation, and we actually didn't talk about the sound wave weakening at all. We just kind of talked about its amplitude, power, and intensity. But now for this next section, which will be in a different video or a live video, we're going to be talking about true attenuation. So what happens when I take the amplitude, the power, and the intensity away from the sound wave? Obviously, I'm weakening it, right? Like anytime you take power, amplitude, and intensity away from something, you're making it weaker. So first we had to learn what those words were so that we can learn how the sound wave is going to respond to the amplitude and intensity being taken away and how it affects our body and what that looks like for the sound wave. So let me know if you guys have any questions. Feel free to discuss with me, send me an email, let me know your questions or thoughts or whatever. You want me to hear you talk about physics, I'll be happy to hear you talk about physics. But shoot me an email and then we'll go from there. I hope you enjoyed today's video and keep studying hard.